Now explaining new topic, multiplication rule of a probability. Now to understand this topic, let me take one simple example. Suppose in a time of raining, what is happening? We suppose three events. Let A be the event that lightning occurs in the sky. Lightning occurs, event of lightning in the sky. B is the event of thundering. C is event of raining. Now, using example of these three events, I am putting here a word symbol, that is, if lightning occurs, then probability of thundering. This means event A has occurred. Event A occurs. Given that event A occurs, means given that lightning occurs, then probability of thundering. First lightning occurs, then thundering occurs. So by definition, it is probability of A intersection B upon probability of A. Now this means probability of A intersection B is equal to probability of A into probability of B by A. So meaning of this statement is that probability that lightning and thundering both at a time occurs. Simultaneously occurrence of these two events, lightning and thundering, that is equal to probability of lightning into probability of thundering given that lightning occurred. So say here this is happening in sequence. Probability of occurrence of lightning and thundering, it is equal to, say first A occurs, then for this into I am speaking word dot, for into I am speaking word and. Lightning occurs, and see lightning has occurred. So lightning has occurred, then next is thundering. So lightning and thundering. But when occurrence of a second event, first has been occurred. So into P of B by A. So this is said to be multiplication rule of probability. So putting here in words that let A and B be events of sample space S, then probability that events A and B simultaneously occurs is given by P of A intersection B both occurs. It is equal to A occurs, and now see A has occurred. Under the effect of A, B occurs. Lightning, and under the effect of lightning, thundering occurs. So this is said to be multiplication rule of a probability. Similarly, we can put multiplication rule of probability for 3 events. For 3 events, we can put rule like this. Let A, B and C be events of a sample space S. Then probability that A, B and C, all three events occur simultaneously is given by probability of occurrence of A occurs and B occurs and C occurs. See how to remember this rule. Probability of occurrence of A intersection B intersection C is, see, first of all A occurs, lightning occurs. Now see, lightning occurred. Under the effect of lightning, thundering occurs. So second event now occurred. First of all A occurred, then under the effect of A, B occurred. Now A and B both occurred. So under the effect of A and B, C will occur. So that is probability of C, given that before C, A and B both occurred. So that is C by A intersection B. In simple story, we can learn this like occurrence of lightning and thundering and raining. Many times it happens. Lightning, thundering and raining, all three events occur many times in this world. So probability of such event is equal to probability of lightning and thundering. But before thundering, this already has occurred. Into, now last is raining. But before raining, A and B already occurred. So here condition is A and B occurred. So this is the rule of multiplication rule of probability for 3 events. So now, so we can see that these rules are derived from conditional probability. Now next is independent events. Independent events means occurrence of a second event doesn't depend on first event. That means for events A and B, if probability of A by B, that means B occurs, then under the effect of a probability of A. So here if there is no effect of a B, then simply this can be written as P of A. If event A is not affected by occurrence of event B, that means probability of A given that event B occurs is simply probability of A. Here probability of B must be non-zero, and similarly probability of B by A, it is P of B, where A is probability of A is non-zero. Then if these conditions are satisfied, then events A and B are said to be independent events. Now see, here probability of A by B is equal to probability of A. Now probability of A by B, that is probability of A intersection B upon P of B, that is equal to P of A. So what is happening here? Probability of A intersection B is probability of A into probability of B. So that means if A and B are independent events, then A and B are independent events, then probability of A intersection B is equal to probability of A into probability of event B. So important statement. This can also be understood here. Say if A and B are independent events, probability of B by A is P of B. Probability of B by A, put here P of B. B will not be affected by A. So it is equal to P of B. So what happens? P of A intersection B is P of A into P of B. If P of A intersection B is not equal to P of A into P of B, then A and B are not independent events, they are dependent events. These events are dependent. So that is meaning of independent events. Now, for three events, A, B and C, for three events A, B and C, if probability of A intersection B is equal to P of A into P of B, probability of B intersection C is probability of B into P of C, probability of C intersection A is probability of C into probability of A. This means a pairwise independent. One more statement. And probability of A intersection B intersection C is probability of A into probability of B into probability of C. If these conditions are satisfied, then these events A, B and C are said to be mutually independent events. If a probability of A is 3 by 5 and probability of B is 1 by 5, find the probability of A intersection B if A and B are independent events. So here A and B are independent events. And as just we discussed, because these are independent events, probability of A intersection B, it is equal to probability of A into probability of B. If two events are independent, probability of their intersection is equal to product of their individual probability. Now values are given This is 3 by 5 and probability of B is 1 by 5. So required probability is 3 by 25. Now next question. Two cards are drawn at random and without replacement from a pack of 52 playing cards. Understand the words given in question. Two cards are drawn at random, but two cards are not taken at the same time from the bunch. Don't take two cards together. Take one by one. See, what is the word without replacement? That means take first card, then don't put it back in the bunch. Without putting back, take second card. So this is the meaning of without replacement. So first card is not kept back in the box. Without putting back, take second card. So here we suppose, let in this experiment of selecting two cards without replacement, in experiment of selecting or drawing two cards without replacement from a pack of 52 cards, we suppose A is the event that first card, see question, find probability that both the cards are black. Both the cards are black. So take a first card, we need it black. So first card is black. Then B is the event that second card is also black. We want both cards black. So second card is black. So we want probability that both the cards are black, that is probability of first card is black and second card is also black. So it is equal to, first of all A occurs, first card is drawn from 52 cards. Now when you perform second action, it will be affected by first action, because after taking first card you have not taken back, you have not kept back in the box. Now when you are going to take second card, there is one less card in the box, in the bunch of cards. So now you have 51 cards. So that means this is affected by this event. So by a conditional event, now second action is conditional action. So here we are using rule of multiplication. A occurs, then B occurs, but before that A has occurred. One card already you have taken. So this is equal to, now probability of A, first card is black. Now how many black cards are there? So there are 26 black cards. So 26 black cards, total number of cards 52 into, now probability of B, B means second card is black. Now you are taking second card which is also black. Now see, this event has occurred. You have taken one black card. Out of 26 you have taken one black card. Now how many black cards are left? So in that bunch there are 25 black cards. So you have to select any one from 25 black cards. Out of Total number of cards is 51. So probability of B is 25 by 51 if A occurs. So this is without replacement. So this is equal to, so this is 26 into 2, 52. So 25 by 102, it is required probability. Now in this question, if suppose I am adding one extra point. In this question, if I remove this word without replacement, instead of that, if I keep word with replacement, in this experiment, if both cards are drawn with replacement, then probability that both cards are black, that is probability that first card is black, second card is black. So how to calculate this probability? See, I have changed one word. Here I have taken this word with replacement. Here it was without replacement. So with replacement means from 52 cards you are taking one card. Now after taking one card you are going to take second card, but before taking second card, put back that first card which you have drawn, put back in the bunch. So with replacement. So whenever you are taking second card, again status is same. Total number of cards 52 as it is, bunch is as it is when you do with replacement. So first time when you take black card, so 26 black cards, so this can be written as probability of A has occurred. First card is black. Now second card is black, but this is with replacement. So when you are going to take second black card, status is as it is, original status, already 52 cards, because with replacement. So no effect on B. So second event will not be affected by A, because number of card remains same, nothing is changed. So that means in this example, these are independent events. A and B are independent events if this condition is given with replacement. So probability is 26 black cards, total 52 cards. Now taking second card again, because with replacement again you have same number of black cards, same number of total cards. So that is 1 by 4. A box of orange is inspected by examining 3 randomly selected oranges drawn without replacement. Say this word, without replacement. Box of orange is inspected by examining 3 randomly selected oranges without replacement. That means you select one orange, randomly taken, then don't replace it. Without replacing it, take second orange, then take third orange. So see, every time one number of orange, one orange will be decreased. Every time in the box, one orange will be decreased. So each next event is dependent on previous one. If all 3 mangoes are good, the box is approved for sale. Otherwise it is rejected. Find the probability that a box containing 15 oranges, out of which 12 are good and 3 are bad ones, will be approved for sale. We need a probability of approving for sale. That means we need a probability that all 3 oranges are good. Now say here in this box 12 are good and 3 are bad oranges. So total 15. We suppose that A is the event that first orange is good, B is the event that second orange is good. We want all 3 oranges good because we want to make it approved for sale. C is event that third orange is good. So probability that box is approved for sale, it is equal to probability that all 3 oranges are good, but they are taken without replacement, one by one. So it is equal to probability of A intersection B intersection C. That means the first orange is good, second orange is good, third orange is good. Now we are taking first orange, that is probability of A. Now first orange is taken, A occurred, first good orange is taken. Now number of orange is decreased in the box in total as well as in good oranges. So second event is affected. So first A occurs, under the effect of A B occurs. Now under the effect of A and B both, C occurs. So when you take third orange, already you have taken 2 oranges. So total number of oranges are changed. Total number of good oranges are also changed. So each next event is affected by previous event. So here we use rule of multiplication. Now first orange is good. So whenever you are taking first orange, 12 good oranges, total 15 oranges. So this will be 12 by 15. Now when you take second orange, second good orange, but when you are going to take second good orange, already you have taken one good orange. So this event is affected. Now how many good oranges are left? 11, and total oranges 14. Similarly, when you take third orange, which is good, again now 2 oranges are decreased in good, so total 10 are left, and in total here 13 are left. So 10 good, 13 total. So every time decrease 1 orange, because all 3 times we need good orange. So this is equal to, here 5 into 2 10, 7 into 2 15, 5 into 3 15, 3 into 4 12. So this is 44 upon 91. So it is required probability. Now in this question, let a fair coin and an unbiased die are tossed. 2 objects are tossed. Let A be the event head appears on the coin and B be the event 3 on die. Check whether A and B are independent or not. Say here, sample space associated with given experiment, putting sample space S. Sample space is, see, coin and die. When you toss a coin, then H may be the first outcome, H. Now with H 1 can appear, with H 2 can appear, with H, so second place it is outcome from coin, then H4, H5, H6. Now if from coin T appears, then on die with T it can come 1, with T it can come 2, T3, T4, T5, T6. So this is sample space. Now event A. What is event A? Head appears on the coin. So A is the event that head appears on the coin. So A is head appears on the coin, that means event A contains these elements in which head appears on the coin. So H1, H2, H3, H4, H5, H6. Then B. B is the event that 3 on die. So 3 appears on die. 3 appears on die, that means these are the elements in which 3 appears on die. So B is event that containing H3 and T3. E intersection B, we find intersection. So intersection is, see, H3, only H3, intersection contains only H3. Now see, we find probability of A. Probability of A is, A has 1, 2, 3, 4, 5, 6 elements. So 6 upon S contains 12 elements. 6 plus 6, 12. So 6 by 12, that is 1 by 2. Probability of B. B has 2 elements. 2 by 12. 2 by 12. That is 1 by 6. And A intersection B. Probability of A intersection B. 1 by 12. 1 by 12. Here it is 1, total 12. Now we want to check whether are A and B independent. Now look here. Check product of these two numbers. 1 by 2 into 1 by 6. So it is 1 by 12. So it is clear that here P of A into P of B is 1 by 2 into 1 by 6, that is 1 by 12. Product of these numbers is 1 by 12. It is same as P of A intersection B. So what is proved here? P of A intersection B is P of A into P of B. Therefore A and B are independent events. Therefore A and B are independent events. Say here, given that events A and B are such that probability of A is 1 by 2, probability of A union B is 3 by 5, and probability of B is P. Find P if they are mutually exclusive events. First case is if A and B are mutually exclusive events, if A and B are mutually exclusive events, then their intersection is empty. So probability of A intersection B is 0. So we shall use this value. Now formula for the probability of A union B. Probability of A union B is probability of A plus probability of B minus probability of A intersection B. This is general formula for probability of union of any two events. P of A plus P of B minus P of A intersection B. Now putting values. P of A union B, it is 3 by 5. P of A is 1 by 2. P of B is P minus, and this is 0. So P is equal to 3 by 5 minus 1 by 2. So P is 6 minus 5 upon 10. So value of P is 1 by 10. That is first case. Now case 2. Case 2. If events are independent, if A and B are independent events, if A and B are independent events, then we know that P of A intersection B, it is P of A into P of B. Now P of A is given 1 by 2. This is 1 by 2. And P of B is P. So we shall use this value in calculation. Now again probability of A union B is probability of A plus probability of B minus probability of A intersection B. Using values in this equation, probability of A union B is, it is 3 by 5, probability of A is 1 by 2, probability of B is P minus, here it is 1 by 2 times P. So that means 3 by 5 minus 1 by 2 is P minus P by 2, that is P by 2. So P by 2 is 6 minus 5 by 10. So P by 2 is 1 by 10. So value of P is 1 by 5. So remember difference between these words, mutually exclusive. Mutually exclusive means intersection is empty. So probability of A intersection B is 0. And independent, A and B are independent, that means probability of A intersection B is probability of A into probability of B. Now with this question, probability of A is given, probability of B is given, and probability of A intersection B is given. We want probability that not A and not B. Say probability of A union B, we are finding value for probability of union. Probability of A union B is, say before finding P of A union B, let me start from question. We want probability of not A and not B. That means what? Not A, that is A dash, complement of event, and means intersection, and B dash, P of A dash and B dash, that is equal to, now using De Morgan, this is probability of A union B whole dash. Now probability of complement of any event X is 1 minus probability of X. probability of complement of any event x is equal to 1 minus probability of x. Basic of probability we are using. Now P of A union B is P of A plus P of B minus P of A intersection B. Formula. Now putting values, all values we are given. P of A is 1 by 2, P of B is P of A is 1 by 4, P of B is 1 by 2 minus 1 by 8. So 1 minus, here LCM is 8. So this is 2 plus 4 minus 1. So 1 minus 6 minus 1, 5 by 8. So value is 3 by 8. Suppose in this question, if we want to find P of not A and B, P of not A and B, that means A dash intersection B. So that is not A means A dash and B. So by formula it is P of B minus P of A intersection B. P of B is 1 by 2 minus probability of A intersection B is 1 by 8. So this is 4 minus 1, 3 by 8. So by this way we can find probabilities. A die is tossed thrice. Find a probability of getting an odd number at least once. So here a die is tossed thrice. So here sample space contains set of triplets x, y, z. Outcome from first die, outcome from second dice, outcome from third dice. So S is set of triplets where x, y, z are elements from 1 to 6. So this is S. So S contains, therefore S contains this by 6 ways, value of y by 6 ways, value of z by 6 ways. That is S contains 6 into 6 into 6, 216 outcomes. Now we take event A. A is the event of getting an odd number at least once. Suppose A is event of getting an odd number at least once in all 3 throws. When a die is thrown, getting odd number at least once in all 3 throws or all 3 tosses. So now we define A dash. What means A dash? That means not getting an odd number. It means not getting an odd number at least once in all 3 tosses, and not getting an odd number at least once, that means every time even number is obtained. So it means getting not at least an odd number, that means every time even number. So getting even number in all 3 tosses That means A dash can be defined as it is set of triplets where x is even, y is even, z is even. So x, y, z belonging to 2, 4, 6. So this element by 3 ways, this element by 3 ways, this element by 3 ways. So this triplet can be formed by 3 into 3 into 3, 27 ways. Therefore, A dash contains 27, that is 3 into 3 into 3, 27 elements. Now what we want? We want a probability of A. So probability of A, required probability is probability of A, that is a probability of getting an odd number at least 1. So P of A is equal to 1 minus P of A dash, that is 1 minus, now what is probability of A dash? A dash contains 27 elements, so 27 by 2, 116. So 216 minus 27, that is 189 upon 216, divisible by 3, it is divisible by 9, 9 into 2, 18, 21 into 9, 189, this is 2 into 9, 18, 24 into 9, still divisible by 3, 7 upon 8. So this is required probability. Now in this question, probability of solving specific problem independently by A and B are 1 by 2 and 1 by 3 respectively. If both try to solve the problem independently, find the probability that problem is solved. Exactly one of them solves the problem. Say here, two students are solving a problem. When first student solves the problem, then if he or she can solve or cannot solve, it will not be affected on intelligence of second student. They both students A and B both have their own intelligence. So solving by both individually are independent events. Occurrence of solving by B or solving by A, it will not be affected by performance of other partner. So these are independent events. If A solves, then B cannot solve, or if B solves, then A cannot solve. If A cannot solve, then B cannot solve. It is not possible. They have their independent intelligence. So these are independent events. So we suppose that A be the event that A solves the problem and B is the event that B solves the problem. So we define this event by these words. A and B are independent events. A and B are independent events. Probability of A is 1 by 2. Probability of B is 1 by 3. So because these are independent event, probability of A intersection B is probability of A into probability of B, that is 1 by 6, because these are independent events. So in such type of stories, when 2 students or 3 students are solving a problem, solving a puzzle, such stories are stories of independent events. Now, first question, problem is solved, probability that problem is solved. When it is said to be problem is solved, see, this is common work, combined work. A problem is given to two students. If anyone can solve, at least one student can solve the problem, it is said to be problem is solved. It is not like that. If both are solved, both students can solve, then it is said to be problem is solved. It is not like that. If anyone, at least one student is solving the problem, that means problem is solved. So that means problem is solved, that means a probability that at least one can solve the problem. Probability that A solves the problem or B solves the problem, that means at least one solves the problem. So it is equal to probability of A plus probability of B minus probability of A intersection B. P of A is 1 by 2 plus 1 by 3 minus 1 by 6. So LCM is 6. So here 3 plus 2 minus 1, 5 minus 1, 4 by 6, that is 2 by 3. Then second is exactly one of them solves the problem. Exactly one of them solves the problem. That means probability that A solves the problem at the same time B cannot solve the problem, or if A cannot solve the problem at the same time B solves the problem. Exactly one solves the problem, that means A solves the problem and B cannot solve problem, or A cannot solve problem and B solves the problem. Now see here, this is A, this is B, this is A intersection B, this is A intersection B dash, and this is A dash intersection B. You can see that both are disjoint. These are mutually exclusive. Both events are mutually exclusive, and if two events X and Y are mutually exclusive, then probability of X union Y is probability of X plus probability of Y, because probability of X intersection Y is 0. So here minus 0. Probability of, if X and Y are mutually exclusive, see here intersection is empty, intersection of these two is empty, so these are mutually exclusive. These are mutually exclusive. If two events are mutually exclusive, then probability of their union is equal to sum of their individual probability, because their intersection is empty. So probability of intersection is 0. So we don't subtract P of X intersection Y. Now P of A intersection B is P of A minus P of A intersection B plus P of A dash intersection B is P of B minus P of A intersection B. P of A dash intersection B. So P of B minus P of, so we are using here results of class 11. So this is P of A plus P of B minus 2 times P of A intersection B. Now P of A is 1 by 2, P of B is 1 by 3 minus 2 into P of A intersection B. Here already calculated 1 by 6. So this is 1 by 2. Two balls are drawn at random with replacement. See here two words can be given: with replacement, without replacement. From a box containing 10 black and 8 red balls. Find the probability that both balls are red. First ball is black and the second is red. One of them is black and other is red. Say here two balls are drawn at random with replacement. First ball is taken. Then with replacement, before taking second ball, replace it. So when you are going to take second ball, status is original in the box. So second event is not affected by first event. Occurrence of first event doesn't affect second event. So these events are independent events. So here two balls are drawn at random with replacement. Because of with replacement, therefore event of taking first ball and event of taking second ball of any color, these events are independent. So this result will be used in calculation of 3 cases. Now case 1. Find probability that both balls are red. So let me take A is the event that first ball is red. Say before that here we showed a number of balls in the box. Here say in the box 10 black color balls, 8 red color balls, total 18 balls. Now first case, let me take A be the event. See here we want both balls are red. So A is the event that first ball is red. B is the event that second ball is red. First selected ball is red, second ball is also red. So we want both balls red. So required probability that both balls are red is P of A intersection B. A is red and B is red. But because this is independent, it is P of A into P of B. Because independent events. Only here discussed independent events. Take any color ball, both actions are independent. So red color ball, so first time red color ball, so there are 8 red colors, so 8 upon 18. 8C1 upon 18C1, that is 8 by 18 into, now second time red ball, but when you take first ball it is replaced in the box, so it is kept back. Word is with replacement, so status is original. So now because first ball is kept back, second time same status, 8 again red ball, so 8C1 upon 18C1, that is, it is 4 into 2 8, 9 into 2 18, 4 by 9 4 by 9, so 16 by 81. Then second, first ball is black, second is red. Suppose A is the event that first ball is black, B is the event that second ball is black, red, second is red. So probability that first ball is black and second ball is red is, first is black and second is red, 1 by 1. But with replacement, so these are independent events, so P of A into P of B. Now say this is black, so black there are 10, so 10C1 upon 18C1, black ball is selected, now put back in the box, so again status is same, total 18. So now second time red ball, so take red ball, so 8, total is same because with replacement. If this question is given by word without replacement, take first ball, don't put back. So in that case events are not independent. In that case here you have to use rule of multiplication. A occurs, then B occurs under the effect of A. So here 1 number will be decreased. Same here 1 number will be decreased, and this will be conditional. Second event will be conditional in case of without replacement, but because of with replacement it becomes independent. So 10 by 18 into 8 by, second ball is red, 8 by 18, so that is 5 by 9 into 4 by 9, so 20 by 81. Then third is, one of them is black and other is red. One of them is black and other is red. That means probability of this event is, say required probability is see first ball is probability that first ball is one of them is black, other is red. So first ball is black and second ball is red, or so put plus sign, probability that first ball is red and second ball is black. So it is like A intersection B dash union A dash intersection B, like this. Probability of first ball is black and second ball is red, or first ball is red, second ball is black, like this. So this means it is equal to first ball is black, that is 10 by 18, and second ball is red, so 8 by 18. Or because these events are, say this event and this event, both are mutually exclusive, nothing common, intersection empty, that's why we keep here plus sign. First ball is red, so 8 by 18. Second ball is black, 10 by 18. So this is, here we have calculated 10 by 18 plus 8 by 18, we are getting same number 2 times. So this is 20 by 81 plus 20 by 81, so this is 40 by 81. So here this is a problem of cards. When you solve problem of cards, say keep remember these numbers. Card means a bunch of 52 cards. Deck contains 52 cards, and groups are identified by these words. There are 13 spade, 13 spade, 13 diamond, 13 club, 13 heart. These are 4 groups, each of 13 cards. So total 52 cards. Now, color wise, 26 black and 26 red. So total 52. Then 4 kings, 4 ace, 4 queen, 4 jack. These are face cards. Total 16 face cards. Sorry, 4 ace, it is not considered as face cards. King, queen and jack, these 12 are face cards. 12 are face cards. These 12 cards are face cards. And 4s, that is cards having picture A. 4s. So remember these words in questions of cards. Now here, probability of E. Cards drawn is a spade. There are 13 spade. So 13 by 52. Probability of F. Card drawn is an S. There are 4 S cards. So 4 upon 52. Then E intersection F. Probability of E intersection F. E intersection F means a card having both property. E intersection F means an S from spade. So S of a spade, there is such only one card. S of a group spade. So only one card. So 1 by 52. You can see that here it is clear that P of E into P of F, it is 13 by 52 into 4 by 52, that is 52 by 52, this is 1. And P of E intersection F is 1 by 52. So this is not equal to P of E intersection F. So E and F are not independent events. These are not independent events. Spade 13, S there are 4, 52 by 52, that is 1, and spade and S, that is 1 card. So 1 by 50, so not equal. Now here, probability of E. So in this experiment only we are asked to take only one card. Card is black. So total how many black cards? 26. 26 C1 upon 52 C1. So 26 by 52. Probability of F. It's a king. How many king? 4 kings. So 4 king out of bunch of 52 cards. And E intersection F, that means having both property. A card element which is in E as well as in F, that means card which is of black as well as king. So king and black, there is only one card. So it is 1 by 52. So here P of E into P of F, it is 26 by 52 into 4 by 52. That is, it is equal to here 13 into 4, 52, 13 into 2, 26, 2 by 52. And 2 by 52 is not equal to, sorry, here I have done mistake. This is color, black color. There are 2 kings with black color. One is from spade and one is from club. Spade and club both have black color. So there are such 2 kings. So here I should keep 2 by 52. And this value is equal to P of E intersection F. So this events, therefore here P of E intersection F equal to P of E into P of F. So events are independent. Now in this question, card drawn is a king or queen. King or queen. So king and queen. So total there are 4 king and 4 queen. There are such 8 cards. 8 cards, 8 elements in E. F contains queen or jack. Queen or jack. Queen, there are 4 queen. Jack, 4 jack. Again 8. So in E 8 elements, in F 8 elements. So probability of E is 8 by 52. Probability of F 8 by 52. And probability of E intersection F, that means a common in both. See, what is common? 4 queens are common. These are common. So 4 by 52. E intersection F has 4 elements. 4 cards are common. So here probability of E into probability of F is 8 by 52 into 8 by 52. That is, it is not equal to 4 by 52. 4 by 52 is probability of E intersection F. So therefore, probability of E intersection F is not equal to probability of E into probability of F. So E and F are not independent events. Say, sorry, here I did mistake in calculation. P of E into P of F. 13 by 52 into 4 by 52. That is, this is 1 by 52. And 1 by 52 is equal to P of E intersection F. So here it is proved that in this first case, therefore probability of E intersection F is probability of E into probability of F. So E and F are independent events.